In the rapidly evolving field of academic research, it is important to understand how to manage the resources. It is necessary to understand what topics and research fields are currently evolving, are promising and worth funding. So thus we determine our business goals as developing such software that will be able to answer the following questions. What topics and research fields are currently trending? What research fields are going to be trending in the near future? What topics and areas can appear in interdisciplinary research? However, this idea may have risks. Incorrectly predicted topic may cause suboptimal distribution of the budget, which might divert the money from actually promising areas. Results of our model so that they should be treated not as obligatory requirement, they should be treated rather as suggestion.
For the data understanding part, we wanted to know if our dataset allows to even evaluate whether predictions are possible or not, because we needed to know if the dataset provides such information. To do so, we firstly tried to know if the topics are decreasing or increasing popularity, and indeed we found out that some topics are more popular, some topics are less popular over time. For instance, machine learning, unsurprisingly, is getting more and more popular over time. However, we also wanted to know if the graph structure allows us to evaluate whether the interdisciplinary topics are going to be more popular in the future or not. To do so, we introduced classical network theoretical features, which are computed as follows. Feel free to pause the video if you want to know more about those. So, indeed they allow to do so, because there is positive or negative, anyways, high magnitude Spearman correlation with the classical features and the topic growth in the future, which suggests that we indeed would be able to build a model which allows us to find out in the future if the interdisciplinary topic is going to be popular or not.
So we choose the dataset, the AXI dataset, which contains 1.7 million entries for the past 30 years. We selected only the last 10 years, so we kept the data from the 2015 to 2025, and also we selected data from the top 15 most popular spheres. Also we cleaned up the data and made several transformations, such as logarithmic transformations. We had skewed data, so we needed to transform it. Also, we made min-max transformation. We transformed the adjacency matrix, and also we had seconds transformation. We had a sliding window of 5 to transform the temporary data.
We choose MLP architecture because we just need to analyze the trends in mathematical article sphere, but not exact answer. So we regularize our neural network with dropout. We stack 2 layers, and we think that it is enough for us. Also interesting is loss function, because if we just use regular MSE loss, then our prediction will be just a zero matrix. So we use alpha equals to 10 and tau equals to 0.5 to tackle this problem. And as the result, you see that loss function decreases till 38 iteration, and we obtain loss equals to 0.31.
As for the technical goals evaluation, we may state the following. Our graph model can predict adjacency matrices that represent the interdisciplinary bonds. However, it lacks prediction of forecasts. so it produces some static result and not one evolving in time. Those adjacency matrices enable us to identify research category relationships.
For the easier result interpretability, we built a specific pipeline. Basically, it's a standard Flask application with the front end and desired API endpoints. The Flask application uses PyTorch to run the sparse graph predictor model to predict the adjacency matrix of further months. To ensure the quality, we limit our prediction ability by this year months only. So it's impossible to predict adjacency matrices further. For the front end, we use the JS, and to display the graph, div3.js framework. So basically, it's a very simple interface with the date selector and the button and the canvas with the graph. We implemented the interactivity with the graph to enable flexibility structure, and the physics don't allow to graph to leave its borders, canvas borders, and it's pressed to the center. And to make the application available, we used the Yandex Compute Cloud. So the front end is available via public API. The one more advantage of the platform we used for deploy is the enhanced monitoring, allowing see the CPU, network usage, and the remaining quota of the